Welcome. Foretell is a project of Georgetown University's Center for Security and Emerging Technology. This presentation provides the why and how of forecasting on Foretell. This is our homepage. Foretell is a forecasting platform where registered forecasters like yourselves make numerical estimates of the likelihood of future events. The goal is to generate forecasts relevant to policymaking at the intersection of security and emerging technologies. There are two types of questions on Foretell. This is an example of a binary question, typically of the form, will X happen by Y? These questions are answered with a single number representing the likelihood the event happens. Questions have several parts to them. In addition to the question itself, at the top, there's a background section providing context for the question, including links to key resources, as well as resolution details about how we will judge whether the event has occurred. Below that, there's a box in which you can add your numerical forecast, followed by another section to provide information about the reason for your forecast. Finally, you can also view the aggregate crowd forecast, including how it's changed over time. The second type of question is based on time series data and asks about the value of X as of Y. There are a few notable differences between binary and time series questions. For time series questions, we request multiple estimates because we want to know not just what value is most likely, but how likely different values are. We call the different forecast intervals bins. Time series questions include the historical data, in blue, juxtaposed against the forecast bins, in pink. The graph also displays the aggregate crowd forecast as of that time. To make a time series forecast, you can either input a different numerical estimate for each bin, or you can use the slider function shown here in the bottom left. Now let's turn to the why and how. Here are the key points we'll cover. First, decision-making is about navigating uncertainty, i.e. forecasting. Second, human judgment is a powerful but imperfect forecasting tool. Third, there are several ways to improve human judgment, including quantification, using the inside and outside views, using diverse sources and methods, calibrating your uncertainty, recording and updating your forecasts, and aggregating forecasts. Finally, we'll see that forecasting is a highly learnable skill. Broadly speaking, decision-making has two components. One, what do you want? And two, how can you get it? Forecasting is relevant to the latter. Consider this decision. Should you bring an umbrella to work? Assume you don't want to get wet, but you also don't want to be saddled with an unnecessary umbrella, particularly if you're going to go out after work. The decision is difficult because of your uncertainty about the questions below. Will it rain on your way home from work? Do you have an umbrella in your office? And will there be an office happy hour after work? If you knew the answers to these questions, the decision would be trivial. So what should you do? One answer is to throw up your arms and say these questions are unknowable, but they're not entirely unknowable. While you can't know for sure whether it's going to rain this afternoon, you have access to a lot of relevant information, including weather reports, how often it rains this time of year, and what the sky looks like. Forecasting is about using this information to reduce your uncertainty and therefore make better decisions. Note that one of these questions, whether you have an umbrella in your office, isn't even about the future. As you'll see, the tools we use to forecast apply equally to uncertainty wherever it lies, whether the past, present, or future. There are many forecasting tools, but consider two: quantitative methods and human judgment. Quantitative methods make a prediction based on data. A simple example is trend extrapolation of time series data. Human judgment, which in plain speak is just intuition, by contrast, can take far more variables into account, but its treatment of each variable is sketchier. It's also often difficult to reverse engineer why one has the intuition they have. Unsurprisingly, given their complementary strengths and weaknesses, the two methods work best in combination. The relative value of each depends on the circumstances. For example, consider you're asking at the beginning of 2020, what percentage of software engineer jobs will be remote in 2020 Q3? A question we had on Foretell. On the left is the quantitative projection, which is based entirely on historical data. On the right is the Foretell crowd forecast. Why the difference? The quantitative projection is not taking into account current events, i.e. the pandemic. In a normal environment, assuming no pandemic, for example, human judgment might add very little to the quantitative projection for this question. But when the environment is changing, and thus history is less predictive of the future, human judgment becomes increasingly valuable. And here you can see what actually happened. The yellow dashed line is the quantitative projection. The blue dashed line is the crowd forecast. And the red dashed line is what actually happened. In this, admittedly cherry-picked, example, the crowd crushed it. To be clear, human judgment has lots of problems. Fortunately, many of them are fixable. Let's discuss some of the big ones. First, ditch the words. They are strictly worse than numbers at communicating forecasts, period. There have been many attempts to standardize what are called words of estimated probability, including a famous effort by Sherman Kent for the US intelligence community in the 1960s, as shown here. Unsurprisingly, many studies have shown that people interpret each of these words to indicate very different likelihoods. This entire exercise seems silly to me. Let's just use numbers. And to be clear, the stakes are high. Among the most infamous examples of imprecise communications of a forecast is the 2001 brief to the president about the very unclear likelihood of a bin Laden attack on the US. Unfortunately, many people are reluctant to use numbers to communicate forecasts. One reason for the number aversion is that many conflate precision, i.e. numbers, with confidence. This is incorrect. As we'll get to in a moment, your prediction and your confidence in your prediction are entirely distinct. You can say, there's a 37% chance of X with both a high and low degree of confidence. A common forecasting error is to overfocus on the specific facts of the thing you're forecasting. This is called the inside view. An alternative view, the outside view, considers the thing you're forecasting as a member of a larger class of things sharing similar properties. Considering the outside view allows you to get a rough estimate of how often things like this occur. Consider the example here. Will your bike be stolen if you lock it outside overnight? Most people too quickly go to the features of their particular situation. For example, how expensive is their bike? How good is their lock? Does the evening seem particularly menacing? A better way to forecast is to first consider the outside view. For example, the rate at which bikes are stolen in this neighborhood, to get a baseline probability, sometimes called a base rate. Assume, for example, that in your neighborhood, on average, one bike is stolen every night out of the 100 bikes locked outside, giving you a base rate likelihood of about 1%. You can then adjust that baseline probability upward or downward based on the specific facts of your case. If your bike is unusually nice, you might conclude that your risk is twice that of the average bike, or 2%. In time series forecasting, you can think of the historical data as the outside view, or base rate, and the features of the future that are unlike the past, for example the pandemic, as components of the inside view analysis. The thinking style that makes one a compelling pundit or dinner party guest, big ideas or grand narratives that explain everything, makes for a bad forecaster. Professor Philip Tetlock, author of Super Forecasting and co-founder of the Good Judgment Project, calls these people foxes, referencing a famous Isaiah Berlin essay. The alternative to a fox is a hedgehog, one who considers different information sources, methods, and competing models. Stated differently, think of yourself not as a single forecaster, but as a committee of forecasters, where each committee member is approaching the question differently. Your forecast should be a committee decision. Nothing we're forecasting is certain, otherwise we wouldn't be forecasting it. Forecasting is as much about how well you know what you know as it is about what you know. Calibrating uncertainty matters for several reasons. First, it's often the tail-end probabilities we really care about. For example, does North Korea have an ICBM capable of reaching New York City? Knowing whether the answer is 1% or 10% matters quite a lot. Another example, how many people will die from COVID? The graph on the right shows worldwide deaths as of April 1, 2020. Imagine you want an 80% prediction interval of deaths by year end, meaning the range for which there's a 10% chance it's above and a 10% chance it's below. The blue and red prediction intervals have similar median estimates, but the red interval is larger, meaning more uncertain. As it turns out, the red interval includes the actual answer, about 1.8 million, and the blue interval does not. In contexts in which it's important to prepare for the worst, knowing what the worst is essential. A second way this manifests: how much you update your forecasts in light of new information. The less confident I am about my forecast, the more weight I should put on others' forecasts, and the more I should change my forecast over time as I learn more. When you make a forecast on Foretell, you're required to leave a rationale. Don't phone it in. Better forecasters leave more detailed rationales and generally comment more. Why is this important? As I just mentioned, you want to update your forecast based on new information. But typically we forget why we believed what we believed. You can address that bias by writing down why you believe what you believe and what would change your mind. Then regularly return to the question, consider what's new and what effect that should have on your forecast. The more uncertain you were previously, the more you should change your forecast in light of new information. Shown here are two actual comments on Foretell that nicely illustrate this process. The first is an original forecast supported by a full inside-outside view rationale. The forecaster explicitly notes they're not confident about the rationale, but want to memorialize it for, quote, epistemic hygiene. The second is an update. The forecaster cites a news article, explains its significance, and why they're increasing their forecast from 8% to 10%. Not coincidentally, the authors of both comments are Foretell pros, meaning they're among our best forecasters. Why is the stock market so hard to beat? Because prices reflect a lot of information aggregated in the form of a price. The same principle applies to forecasting. No individual forecaster will have access to all the relevant information, and they'll bring their own distorting biases to the information they have. By aggregating many forecasters' judgments, we have a forecast that reflects more of the relevant information and that at least partially cancels out each forecaster's biases. Recall the previous point about using diverse sources and methods, i.e., thinking of yourself as a committee of forecasters. It's based on the same principle. Hedgehogs are better than foxes, and a group of hedgehogs is better still. In the diagrams here, the red dots are bits of information relevant to a forecast question, and the blue circles are individual forecasters. Consider three features of a good crowd. First is knowledge about the topic, the number of red dots in each circle. Second is diversity, how much the blue circles cover the entire relevant space of information. Third is skill, how good are the forecasters at the things we've been discussing. A large body of evidence supports the efficacy of aggregating forecasts. One of the most famous examples is Phil Tetlock and Barbara Meller's Good Judgment Project, whose forecasters outperformed intelligence analysts with access to classified information. How do they do this? One likely reason is diversity. The intelligence analysts worked together and considered similar information sources, which means they're more like the crowd on the right than the crowd on the left. Another likely reason the Good Judgment Project forecasters outperformed the intelligence analysts is skill. While the Good Judgment Project's forecasters were not subject matter experts, they were more experienced forecasters than the intelligence analysts. This matters. Fortunately, it's also highly learnable. The Good Judgment Project showed that a 1-hour training module covering much of the same techniques we've been discussing, led to significant and lasting improvements in forecasting. So how can you become a better forecaster? First, you can read more about the ideas covered in this presentation. 2 books I highly recommend are Daniel Kahneman's Thinking Fast and Slow, and Phil Tetlock and Dan Gardner's Super Forecasting, The Art and Science of Prediction. Second, you can take a training course. All Foretell Pro forecasters have taken Good Judgment Inc.'s training program, which I highly recommend. Third, you can forecast on platforms like Foretell. Other forecasting platforms I encourage you to check out are Good Judgment Open, Hypermind, Metaculus, and Predictit, all of which focus on different types of questions. Finally, you can incorporate forecasting into your daily life. How long will a work project take? How long will your current relationship last? Regularly making and recording forecasts like this is good practice, and it's also fun. Another game I enjoy focuses on calibrating uncertainty. Think of any Googleable question, like, how far away is Pluto? What's the population of Myanmar? When was beer invented? For each, provide an 80% confidence interval. For example, I'll guess it's 80% likely that Pluto is between 1 billion and 10 billion kilometers away. Then look up the answers. If you're well calibrated, you should be right 80% of the time. If you're right less frequently than that, you're overconfident. If you're right more frequently than that, you're underconfident. And just because I like symmetry, we'll conclude with the same key points. Thank you for joining us today, and happy forecasting.